So this is the example for element PA. So that is, where is it? Way down here. Whoops. There we go. It's way down here. So we're going to do the electron configuration and noble gas configuration for that. So just as a quick reminder, this block here is S, and you can think of HE being right here. This block here is P. This block in the middle is D. And then this block down here is F. And S and P have the same energy level numbers, so 1 through 7. And then specifically D is 1 less than S. So since here we're on the same line where it's 4 in S, that's 3 in D, so that's going to be 3, 4, 5, 6, and then F starts at 4, so 4, 5. And you can see that we go in the order of the numbers. So here we're at 56 and here we're at 57, so this is sort of inserted here, and then here we're at 89, so 88, so this is sort of inserted right there. So as we cross the thresholds, we're going to need to write those numbers. So I'm going to first start at the top with hydrogen and helium. So there I'm in 1s, and I have 2 electrons, the hydrogen and helium electron. There's nothing else in that row. So now I'm going to go here. That's 2s, and I have lithium and beryllium, so that's 2s2, and then I'm going to head over here, and I'm in 2p, and I have 1, 2, 3, 4, 5, 6 elements. Then I'm going to move down to 3. So I have 3s, and I'm at 1, 2. And then as I go across, I'm at 3p, and I'm at 1, 2, 3, 4, 5, 6. And then I move down to 4s, and I have 2, and I'm going to just push this up a little. And as I keep going across, I'm hitting 3d, so that's what I'm going to write next is 3d. And then I have how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 electrons there in D. And then as I move past D, I'm going back into P. And remember, the energy levels match S. So I'm going back into the 4th energy level, and I'm on 4P. And how many electrons? 1, 2, 3, 4, 5, 6. So 4P, 6. Now I'm going down a level again into 5s. So 5s, and I have 1, 2. So 5s2, and then I'm going across that into 4d. And I'm going all the way across 4d, so that's 4d10. And then I'm going into 5p and going all the way across, so that's 5p6. I'm just going to go down onto a next line here, so that's 5p6. Then I'm going to go right here into 6s. So now I'm in 6s2, and here I'm going into 6s, but after 56 is 57, so it's actually down here. So I'm going into 4f. So I'm going to write 4f. And then how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It should be 14. Actually, this one is actually right there. If you were to land on it, you would actually call it D1 instead of F1, but there are only 14. So, whoopsie, this is just a weird periodic table where it didn't stick it in there. 14, and then I go back up to here, and I'm at 5, which was right here, 5D. And then, like I said, this isn't a blank spot, right? That's not a blank spot. It's actually an element. So that counts as 1. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5D10. So we're going all the way across 10, and we're hitting P again. So we're at 6P. And then we're going all the way across P, so it's 6P6. Right, we're going all the way across. And we're going down to 7S. So 7S2. And then here's where it can get a little tricky. So because I'm landing in my F, I'm not just going past it. In the 6 In 6s, we went past, right? We went all the way through. So because of that, we just lumped all of our D's and F's together. But remember what I said about LA being like actually in this spot. So it's in the D orbital. These are technically my F's right here. These are also technically your F's. You only have 14. So this AC is technically right here in that spot as well. But because we go in order of numbers, we have 87 and 88. So that's where our 7s2 came for. But then we have 89 next. So 89 is this actinium. So that is technically, let's see, what are we on? 6. That's technically 6D1. So that's what we would write. And then we have 5F. Because that's what we passed. We passed our 6D1, and then we went into 5F, and we have 2 electrons there, so 5F2. So it can get a little confusing if you are landing in the F orbital, if I'm asking for an element in the F orbital. If you're going past the F orbital, like here, we went past the F orbital, right? Basically in this section. We didn't write 6s2, 5d1, 4f14, 5d9, and then 6p6, right? We just added these two together since they're in the same energy level and the same orbital. So when you're going past it, you can lump it like that, but when you actually land in the F orbital, you can't forget to include that D1. It's either a 5d1 or a 6d1, depending on which energy level you're in, either here or here. When you're landing in the F orbital, either here or here. So that's really the hardest part of that. Doing the noble gas configuration, I just want to do that quick as well. I would go to the noble gas that's before protactinium, which is right here. It's radon, right? This is inserted here, which means that the one right before it is radon. So I would put radon in brackets, and that indicates that I'm saying that the entire electron configuration for radon is what we have. And then I am going to go here into 7s2, and then again I still have that 6d1 that is right there, and then I have the 5f2, which are these two right here. So the end part of my electron configuration should match the end of my noble gas configuration. These brackets here are just accounting for all of this, so we don't have to go through and write like the whole periodic table. Okay, so that was the electron configuration and noble gas configuration for PA protactinium.